Okay, let us try to solve the problems on the work and heat today. Okay, so remember all the formulas. Hope you have the screenshot of that. Remember all the formulas. Whenever I ask you, just be in a position to tell those. We shall solve all this today. Okay. Okay. The first problem says, I want everyone to answer while I'm solving it. Okay, and everyone to look at it. Okay. So keep that screenshot with you always, which is giving you all the formulas which are related to that. And before we start something, we shall look into this. This is known as a PVT conversion equation. Okay, PVT conversion equation in the sense from state 1 to state 2, if you have certain values of pressure and volumes, but if you don't have the temperature, then you can find by using these expressions. So for isobaric, isochoric, and isothermal, there is a common expression which is known as P1 V1 by T1, that is equals to P2 V2 by T2. So this is common for isobaric, isochoric, and isothermal. And adiabatic and polytropic have a similar sort of expressions which says P1 by P2. I said it is always P1 by P2 and it is always V2 by V1. So P1 by P2 is equals to V2 by V1 whole to the power of gamma, that is equals to T1 by T2 whole to the power of gamma divided by gamma minus 1. See, P and T is always match. Okay, if it is P1 by P2 here, here it is also T1 by T2. Keep this in mind. Okay. And similarly for the polytropic process also, where gamma is replaced with the value of n here. So it is P1 by P2, that is equals to V2 by V1 whole to the power of n, that is in turn equal to T1 by T2 whole to the power of n divided by n minus 1. Take a screenshot of this, everyone. Taken? Yes?
Yes, sir. Yes.
Okay, now you even take the screenshot of this, which gives you the idea of all the process and work done in that particular process. Isobaric, isochoric, isothermal, adiabatic, polytropic. Take a screenshot. Done? Taken?
Yes, sir.
Super. Next, you need to understand what is an expansion and a compression process, is it? An expansion process is one in which the pressure gets decreased or increased.
Decrease.
Decrease. So what happens? Your pressure gets dropped. So if your process is, if he has said an expansion process, you have to draw a PV diagram like this, indicating its downward, so that it indicates that it is decreasing its pressure. Clear? Similarly, when he says the compression process, you should go in a reverse direction where pressure gets increased like this, pressure gets increased. Okay, so that's why it is like this. So even take the screenshot of this particular thing. Done? By guys, be quick from now. Done?
Yes, sir. Yes.
Yes, sir.
Okay. Now we shall try to solve. See, keep all the three screenshots with you. The number one is the formulas for the different processes. Number two is what? The PVT conversion equations. And number three is how we have to write it for an expansion, how we have to write it for an compression. Keep these three screenshots in your gallery always. switch between the apps so that you can answer whenever I ask you. Keep this in mind, okay? Now, let us look into the first problem and try to solve this. Consider a gas contained in a cylinder as a system with an initial pressure being, see, initial pressure, I'll just write it here, initial, okay? Pressure means I'll write it as P here. Initial pressure in the sense how much he has given initial pressure, 210 kPa. Always write in Newton per meter square. So it is into 10 to the power of 3 newtons. Always I will write this in what? Newton per meter square. It has 210 into 10 to the power of 3 newtons per meter square. Corresponding volume is, so volume we have to write it in meter cube. So volume is how much? 0.04 meter cube. Okay, that is the volume. Next, calculate the work done when the volume of the gas increased to 2. That is the final state. In the final state, the volume gets increased how much? It increased up to 0.15, he says. Okay. Okay, he has given the two cases here. This is the case 1 and this is a case 2. That means the volume reaching from 0.04 to 0.15 is being governed in two cases. Let us even look into that. Okay. The case 1 I'll be writing here. Case 1. And case 2 we will solve parallelly here. Okay, first we should have to identify which process it will be. Okay, PV, PV. Okay, fine. Now read the statement given for the case 1. By heating at constant pressure. That means which process? Constant pressure in the sense which process?
Isobaric.
Very good. So it is from state 1 to state 2. And how does an isobaric process represented on a PV diagram? It is a horizontal line. So it is as such here. So this is case 1. Case 2. Pressure inversely proportional to its volume. Name the process where pressure is inversely proportional to its volume. Which process? Where the pressure is inversely proportional to its volume.
Thermal, isothermal.
Excellent, Sujan. Wonderful. So it is isothermal process. So how does the isothermal process is represented on a PV diagram?
Curve.
It's a curve. So it is from here to here. That is state 1 to state 2 like this. So this process is what? This is
Curve.
isothermal process. Okay. Now what I have to do, first of all, what I have to do, man, in this particular problem? Calculate the work done, he has asked. Okay, I need to calculate what? I have to calculate the work done. So, what is the formula to calculate work done from 1 to 2, which is isobaric? Look at the screenshot and give me the value, give me the formula. Work done from 1 to 2, which is isobaric. Guys, I want everyone to concentrate. This is very, very important.
P into
It
V2
goes
minus
on
V1.
P into V2
continually.
P
minus
into
V1.
V2 minus.
It is P into V2 minus V1. So initial state, I will consider as a state 1. Final state, I'll consider as state 2. Okay. Now, you know the value of P, which is 210 into 10 to the power of 3 into V2 is how much? 0.15 minus V1 is how much? 0.04. So calculate and give me the value.
23,100.
All of you keep your calculators with you. Okay. So it is how much? 23,100 was the one answer. Is that right?
Yes, sir.
Is that right? Okay. So I can write it as 23.1 kilojoules. So this is the answer for the case 1. Now next for the case 2, W1 to 2 for isothermal process. So isothermal process, how many formulas you have, man? How many forms of the formulas you have for an isothermal process?
Six.
Six forms are there. Yes, Mohan. So in those six forms, which form should I choose, keeping in concern with the parameters which are available? I have the value of P1. I have the value of V1. I have the value of V2. So with these three values, which is that form so that I can consider to calculate my isothermal work done?
First one.
First one.
First one. So what is
First
that?
one.
It is P1 V1 into ln of V2 by
By
V1,
V1.
correct? Substitute the things, man. P1 is how much? 210 into 10 to the power of 3 into V1 is 0.04 into ln of V2 is 0.15 divided by 0.04. Menton, Wayne, Swaroop, all of you are concentrating or not? Anish, are you there?
Yes, sir.
All of you guys. Karthik, Wayne, Swaroop, Chirant.
Yes, sir.
11102.74.
So the work done from 1 to 2 in an isothermal way is equals to how much? Give me in the kilojoules directly, Mervin. Give me in the kilojoules.
Uh, 11
1, 1,
102.
11 point.
102.
Okay, 10
102.
kilojoules. Okay. So this forms the end of the problem where you'll get 8 marks for just application of the concepts you have learned. Understood this problem? Any doubts here? Any doubts in this particular problem? Do not have a calculator. You can use it in the phone. There are multiple applications which give you the similar functions which has a scientific calculator. So you can download it and keep it ready, Marvin. Do not waste the time. Any doubts in this problem? Shall we move on to the next problem? Any doubts, guys?
No, sir.
Okay. So the next problem, try to solve it once again. Okay, so next problem is this. A gas expands from an initial state where the pressure is 340 kPa. So first thing what you have to do, you have to draw the state table. So first pressure in the units of Newton per meter square and volume in the units of meter cube. Okay, first initial state is 1. How much is the pressure? Respond, guys. If you do not respond, then it will take more time. Respond. How much is the pressure at state 1?
340 kPa.
340
240
kPa.
kPa.
So 340 kPa in the sense it is 10 to the power of 3 Pascal. Okay. The volume is how much? 0.0425 meter cube. The final pressure is how much? 136 into 10 to the power of 3 kPa. That is at the state 2. The relation between the pressure and volume of the gas is given by, so it is relation is being given, which is PV square is equals to constant, which implies the value of N to be 2. If the value of N is equals to 2, can I judge which process is this? I need to calculate the work done anyhow. That is the question asked, work done from 1 to 2. Before I calculate the things, I must know which process is this. So here he has given the value of n. So if
Polytropic.
Topic.
excellent, excellent. So how does a polytropic process look on a PV diagram?
Curve.
It's a curve.
Curve.
So I have plotted a curve. Whether it should be a downward or upward, for that thing to be decided, I have to look for this particular sentence here. He says the gas expands. That means it is an expansion process. If it is an expansion process, it should be downward or upward.
Downward.
So it is an expansion process from state 1 being here and state 2 being here. Just for the PV diagram, you'll get 2 marks in your examination. Now, guys, what is the work done expression from 1 to 2 for a polytropic process? What is an expression?
P1 V1 minus P2 V2 by n minus 1.
Excellent. So it is P1 V1 minus
Minus.
P2 V2 divided by n minus 1. Okay. Do I have all the values here? Do I have all the values? I mean to say I have the value of P1 here. Yes. I have the value of V1 also. I have the value of P2 here. But do I have the value of V2?
No, sir.
I don't have the value of P2. So I should use the PVT conversion equation to calculate the value of missing parameter. That is PVT conversion equation. Which process is this? This is for the polytropic process. Yes, everyone. For the polytropic process, give me the PVT conversion equation. The second screenshot. Yes.
P1 by P2 equal to V2 by V1 power n.
P1 by P2 equal to V2 by V1 whole to the power of n. That is in turn equal to, Marwan,
T1 by
T1 by T2 whole to the power of n divided by
n
n
by
minus
n
1.
minus 1.
So I will just consider the first two, where it is P1 by P2 is equals to V2 by V1 whole to the power of n. From here, I need to extract the value of which one? V2 is it? I need to extract the value of V2. Just extract the things. How to extract it? How to extract it? So it is nothing but V to the power of n and V1 to the power of n. Okay. From that, if you transfer n to the either side, what it will be? If you transfer n to the other side, it will be P1 by P2 whole to the power of 1 by n. That is equals to V2 by V1. Now from this, I need the value of V2, which is nothing but V1 divided by P1 by P2 whole to the power of 1 by n. Am I correct in extracting the expression for V2?
Yes, sir.
Yes, sir.
Okay. Just substitute the values, guys. Okay, I'll just shorten it up. So V1 is how much? It is 0.0425 divided by P1 is 340 into 10 to the power of 3 divided by 136 is P2 into 10 to the power of 3. Its whole to the power of 1 by n value is how much? N value is 2. From this, what is the value of V2?
0.0269.
0.0269 is the value. Everyone got the same thing? So once you got the value, what you have to do, you have to update back in the state table. So it is 0.0269 here. I think you have the value of P1, you have the value of V1, you have the value of P2, and you have the value of V2, and even you have the value of n. I think there is no difficulty in calculating the polytropic work done, which is given as P1, just substitute the value, it is 340 into 10 to the power of 3 into V1 is 0.0425 minus P2 value is 136 into 10 to the power of 3 into V2 value is 0.0269. This whole divided by n minus 1, in the sense it is 2 minus 1. So give me the value from work done from 1 to 2, which is polytropic process.
One zero seven nine 1.6.
Okay, give me the value in kilojoules.
Excuse me, sir.
Yes, Lucky.
Sir, how did you get the value of n equals to 2, sir?
So he has given the gas expands according to the relation. Look here, Lucky. He has given
Yes.
PV square is equals to constant. Okay.
Okay.
So PV square is equal to constant. The general representation
Okay.
of that
Square.
particular thing is PV to the power of k is equals to constant, right?
Yeah.
So the k value is n value is 2. That's it. Simple.
Okay, that got it.
Okay.
Sir, and why it is polytropic, sir?
10.79.
Huh? Why
Why
it
it
is
is
polytropic? Muhammad Khalid. So look here, if the value of n is equals to 2, that means the value of k is equals to 2. Name the process, have a screenshot number 1 with you, name the process where the value of k is not 0, not 1, not infinite, nor equal to 1.4, which is the ratio of specific heats. Name that process.
Yes, sir, got it, sir.
Got it?
Polytropic.
Very good.
Yes.
Give me the value, guys. Be fast, be fast. Give me the value.
10.79.
10.79 kilojoules.
It's 10.79 kilojoules. Whether all of you got the same value, I observe only 3 to 4 are working. I might ask anyone, whoever is not answering the questions, they will be directly marked 5 classes absent straight away. Because I mind the importance of this particular problem rather than the importance of the attendance. Keep this in mind. This is damn important problems. I want everyone to do it and work on it. Understood this particular question? Any doubts here?
So can you please explain how you transfer the power in that P1 by P2?
Okay,
No,
fine.
sir.
Okay, fine. See. So here it is what? P1 by P2 is equals to V2 by V1 whole to the power of n. If you transfer n to the either side, what it becomes? Suppose there is a 2 square here and there is a 4. 2 square is equals to 4, right? Yes or no?
Yes,
So
sir.
Yes,
if
sir.
you
Yes.
transfer 2 to the either side, what will become? It is nothing but the square root of 2, which is 1 by 2 times of 2, right? That means if there is x to the power of n and there is a y here, and you want to transfer the value of power to the RHS, it would become y to the power of 1 by n. Similarly, I have done it. Cleared? Who asked this question?
Me, sir, Sushant.
Sushant, cleared with
Yes,
this?
sir.
Any doubts again?
Yes, sir. Yes. No, sir. Okay.
Okay, fine. So just a simple mathematics here, man. When you transfer
But
power to the other side, it becomes a reciprocal of it.
okay, sir. Okay. Okay.
Any other doubts, guys, in this problem? Just observe the problem, what was asked and how it was carried out. And similar problem we will solve. Okay. And as I have written here, that the same thing will be forwarded to you as a notes. Okay. Because there is no time. I'm not allowing you to copy the things in your notes. Same thing will be sent to you. Take take a piece of paper and be working along with me. Then only you'll learn. Okay. Done with this? Shall we move to the next?
Yes, sir.
Shall I?
Yes, sir.
Yes,
Yes,
sir.
sir.
So here is the next problem. I think it has been calculated already. Let us see. A piston. This is an open challenge for all of you, man. I give you 3 to 4 minutes of time. I only expect the state table, the PV diagram, okay, and which process you have to indicate. And whoever does it, if he is ready and he can just show his paper by presenting himself. Okay, let us see who does it. A piston compresses a gas, so this is a reverse to the previous one. So this is a reverse. A piston compresses a gas in a cylinder during a quasi-equilibrium process. Okay, the pressure the cylinder varies accordingly is PV to the power of 1 by 4 is equals to constant. So this is the gas compression equation. Initial pressure in the cylinder is so much, and the initial volume of the cylinder is so much. Compute the work done of the gas if the final volume is this much. So this has been asked for 6 marks. I expect a state table, a PV diagram, and to name the process. I give you 3 odd minutes. Once you have done, you can just call me switching on your mic. Okay. Meanwhile, give your attendance. Abdul Rahim, Akash, Bharatesh. Devdarsh,
Present, sir.
Arpit, Sher, Hazim,
Present,
Shishan,
sir.
okay, and Kumar, Kishan Kotian, Lucky,
Present, sir.
okay, Malatesh, Roy, Marvin Pinto, Mohammed Khalid,
Present, sir.
Yes, sir. Present.
Mohammed Munawar, Mohan Chandra,
Present, sir.
Sir
Atsuray.
Abdul Rahim, sir.
Where were you, man, Abdul Rahim?
Sir, my network issue, I was left in between.
Mohammed Suray.
Sir, Ashur also present.
Sir,
Hmm.
is an isothermal equilibrium.
You know, Narendra? Yes.
Isothermal equilibrium.
Isothermal process ಅಂತ ಜಡ್ಜ್ ಮಾಡ್ತಾ ಇದೆಯಾ ಫಾರ್ isothermal process PV to the power of K is equal
Polytropic.
to constant. The value of
Polytropic,
K
sir.
should be equal to 1. Hello.
Polytropic.
Sir, ಹೇಳಿ sir. Best ringtone series. Yes, man. Awesome series. Have you watched Scam 1992?
Yes,
The
sir.
only the only thing I got admired is his
Yes, sir.
personality, his
Arshad Mehta.
attitude.
Arshad Mehta.
Yes, exactly. So his attitude was uh, beautiful and throughout the series.
And Pratik Gandhi's acting, sir.
Yeah, yeah. Acting skills, his attitude was awesome. ಓಕೆ ಮಿಡ್ ವೇ ಫಿಲಿಮ್ ಈಗ ಸದ್ಯಕ್ಕೆ ಬಿ ಟಿ ಡಿ ನೋಡುವ ಎಲ್ಲೋ ಇದ್ದೆ ನಾನು ಹ್ಯಾವ್ ಎನಿವನ್ ಸಾಲ್ವ್ ದಿಸ್
Adiabatic.
Adiabatic. Anish, I guess you observe this value, right? 1.4, so it is adiabatic, correct?
Yeah.
Yeah, I am right. Any other answers? Marvin, have you drawn it?
Polytropic, sir.
Polytropic, okay.
Yes, sir. Somewhat.
Okay, Marvin, can you just present yourself?
I'll on my camera.
Sure. Okay, compression, very good, superb. PV, it is not PV is equals to 1.4. PV to the power of
Okay.
1.4 is equals to constant. Okay,
Constant.
just change that. And work done, always you have to write W1 to 2 polytropic process. Okay, very good. State table, where is the state table, Marvin?
I'll do, sir. I didn't.
Very good, very good. So that is the things. Okay, so here you can see. So since it is a compression process, it should move upward like this. It should go upward. Okay, since this is a compression process. If it was an expansion process, the pressure gets decreased, so it should be downward like this, like this, like this. If it is an expansion process, now it is a compression, so it should go upward like this, upward like this. Okay. Now, yeah, so here is a state table, okay, where P1, V1 values are given. And I think some values you need to calculate here. Okay, final volume is given, initial volume is given, and P1 is given, but P2 is not given. Okay, this is the calculated value. In order to calculate it, which thing you require? You require a PVT conversion equation for a polytropic process. Now, I was explaining, and Anish Pinto, you said it right, that it could be an adiabatic process. Okay, why? Because the value of K here given is 1.4. Okay, but 1.4 value is for the air, atmospheric air. The value of gamma is equals to 1.4 is for the air, atmospheric air. But here he has mentioned gas. And he has not mentioned which type of gas. And we don't know the value of gamma for the gas. That's why we have considered it to be a polytropic process. Clear, Anish?
Yeah, sir.
Okay. So first and second, you just equate in order to know the value of P2 here. Okay, extract the value of P2. Just you have to transfer this to the other side. You know the value of P1, substitute it. You know the value of P2, substitute it. You know the value of V1, substitute it. And the P2 value can be calculated as such. Once the P2 value is calculated, I think there is no difficulty in calculating the polytropic work done, which is stated as P1, V1 minus P2, V2 divided by N minus 1. You know all the values, substitute it to get the value of polytropic work from 1 to 2, which is negative 8.809.35. Why it is negative? Can anyone answer? It is, if you calculate it, you'll get a negative value. Then here it is negative. Why should come negative?
Work done is on
It is
the.
Excellent, excellent, Muhammad Khalil. It is work done on the system. So compression in the sense you must work on the system to compress a gas. Expansion in the sense it can occur on its own, but compression you need to work on the system. If you are working on the system, then it is negative. Very good. Okay. So compression is nothing but work done on the system. That's why it is negative. I haven't even highlighted that portion here. Okay, any doubts? Similar to the previous problem here. Any doubts in this? Any doubts?
No, sir.
Okay. So I want, okay, you to try this particular thing. Just drop away everything. Okay. So this thing is given. Determine the total work done with the gas system following the expansion process as shown below. So how many processes does it contain here? Guys, how many processes does it contain?
2.
So one process is A to B. Okay. The second process is B to C. That means you need to calculate what is the work done from A to B and even what is the work done from B to C. Then you have to add both the things. That is WAB plus WBC. You have to calculate and add it. So that is what it is required. Now, I have to judge two processes here, right? So this is one process, A to B. Which process is from A to B? Can you just say? Excellent.
Isobaric.
Isobaric process. Isochoric.
Sorry, sir, isobaric.
Isobaric process from B to C. Since it is a curved line, I can expect it to be an isothermal, I can expect it to be an polytropic or an adiabatic. But for that, he has given a hint here. PV raised to the power of 1.3 is a constant. Therefore, the value of K is 1.3. That means it is not 0, it is not 1, it is not infinite, nor equal to the value of ratio of specific heats, which is gamma. It is just, it is just 1.3. So which process from B to C?
Polytropic.
So I can judge it to be a polytropic process here. Okay. Draw the state table, which is P into V here. Okay. How many states are there? There are 3 states: A state, B state, and C state. Okay. And here, okay, it is not visible clearly. Just write it once again. It is 0.2, 0.4, and 0.8 in meter cube. And it is 50 bar here. Now, let us update the values. Pressure at state A,
50.
50 watt. I want this to be in Newton per meter square. I want this to be in meter cube, right? 50 bar. That means 50 bar. I have to convert this particular thing in Newton per meter square. How much?
Into 10 power 3.
ಅದು ಕಿಲೋ ಆಗುತ್ತಲ್ಲ ಪ್ರತೀಕ. How much is 1 bar?
10 to power 5.
10 to power 5.
Excellent. So it is 10 to the power of 5 Newton per meter square. Same thing. So it is 50 into 10 to the power of 5 Newton per meter square. Newton per meter square is nothing but again Pascal. Okay. So 50 into 10 to the power of 5. What is the pressure at B? State B. Pressure at state B.
50 into 10 power 5.
Same thing. So it is 50 into 10 to the power of 5 again. What is the volume at state A? Volume at state A. How much?
0.2.
0.2. Now, the volume at state B. The volume at state B. 0.4. Last thing, the volume at state C.
0.8.
The volume at state C.
0.8.
0.8. Okay, so this many things I have got, I have extracted. Now, so the total work done is equals to W A to B, which is it's isobaric process. Okay, isobaric plus W B to C polytropic. Okay. Now further, what is WA to be isobaric? What is the expression to calculate W1 to 2, which is isobaric?
P into V2 minus V1.
So P into V2 minus E1 for 1 to 2. Then it is P into VB minus VA for A to B, correct? Just replacing 1 to 2 with A to B. Okay? Got it, everyone?
Yes, sir.
Okay. Now, what is the work done expression from 1 to 2, which is polytropic?
P1 V1 minus P2 V2 by N minus 1.
So 1 to 2 is P1 V1 minus P2 V2 divided by N minus 1. B to C is PB VB minus PC VC divided by N minus 1. Clear? Just replacing 1 to 2 with B to C. Any doubts in this?
No, sir.
Okay, fine. So in order to calculate the work done, is there any missing value?
P2.
PC, sir.
VC.
PC I have to calculate. So PC value is not known. How do I calculate the value of PC? How do I? What is the provision? How to calculate the value of PC?
PC by PB by PC
Uh,
is equal to VB by VC power N.
So ಏನಂತಾರೆ ನರೇಂದ್ರ? Very good. ಅದನ್ನ ಏನಂತಾರೆ? What you have used? Very good, Narendra. Happy. What you have
Sir,
used? What is that name given to that equations?
PVT conversion equation.
Excellent. So for that, you have to use the PVT conversion equations. PVT conversion equations for which process? From B to C you have to use here, right? From B to C. So it is polytropic process. Polytropic process, PVT conversion equation is given as P1 by P2, that is equals to V2 by V1 whole to the power of N, that is equals to T1 by T2 whole to the power of N divided by N minus 1. This is for 1 to 2. Now the process is from P to C, so it is PB by PC, that is equals to VC by VB whole to the power of N, that is equals to TB by TC whole to the power of N divided by N minus 1. So this was from 1 to 2 and this is from B to C. So what you have to do, you have to replace 1 with 2 and 2 with C. Okay, so consider this thing here, consider this thing. So that what you need the value of PC here. So PC is equals to, it implies PC is equals to PB divided by VC by VB whole to the power of N. Substitute all the values, get the value of PC. Once you get the value, use this equation which we have summed it up. Take this equation 1 and calculate the value of W for the whole. I want answers from you. Let us see who solves this. Apart from Pratik, Mervin, Muhammad Khalid, Aditya Shetty. So apart from these 4, I want others to answer this. I might ask anyone now. Let us see who's there. parallelly. Give your attendance. Not to waste the time. Mohammed Surey, Nishan, Nitesh, Numan.
Present, sir.
Okay, Nitesh and Numan both are there. Pradeep,
Present, sir.
Praveen,
Yes, sir.
Faith. Nitesh, I mean,
Present,
okay
sir.
then. Yes. Next, Raj Prasad, Rajat, yes, Madiwal,
Sayanur present, sir.
Syed Anwara. Syed
Yes, sir.
Anwar, I have not called you yet, man. Wait.
Sir, Abdul Rahim present, sir.
Abdul Rahim, I have marked you. Hey, solve the problem, man, all of you. Don't worry about the attendance. Solve the problem. Rajat S. Medival, Rakesh GM, Ram Prasad, sorry, Ramachandra,
Present, sir.
Ritik Lobo,
Present, sir.
Syed Anwar, Sohan, Siddesh BN,
Present, sir.
next to Saurabh Shetty,
Present, sir.
Srinivasan, Stephen,
Present, sir.
Sujan,
Present, sir.
Shant,
Present, sir. Present.
Vaibhav, Varun,
Present, sir.
Nish,
Present, sir.
Marvin, Wayne,
Present, sir.
Swaroop,
Present, sir.
Kirant,
Present, sir.
Mendan Karthik,
Present, sir.
Darshan Shetty,
Sir, is network issue, sir. He is going and coming. He
okay,
messaged me, right? Yes.
Manish, Anish Pinto,
Present, sir.
Prakhat J,
Present, sir.
Praveen Nair,
Present, sir.
Abdul Sami, Aditya
Present, sir.
Shetty,
Abdul Sami
Marvin.
present.
Present, sir.
Sir, Marvin Land, sir.
Okay, I have marked you. Amal,
Yeah, thank you, sir.
Present, sir. Amal present.
Sir, Abdul
be here
Sami.
today. Abdul Sami, I have marked you. Okay. Amok be here today.
Can we leave, sir?
Hey, who? Solve model. What is the answer? PC. What is the answer? Prakhat. Prakhat, what is the answer for PC and WM?
Sir, Amar present.
You have marked this. Omar, Chandan Rao P, Chirayu, Cyril Vikas. Okay, Chirayu is there. Cyril Vikas is there. Darshan Shetty,
Present, sir.
Midlaj, Narendra Naik, Umar Zaidan.
Narada present.
Okay, Umar has given. Pratik Kesi,
Yes, sir.
Achana Shetty. Okay, Ritesh Kumar. Okay, next is Vishnu Raj. Muhammad Khalil. Okay. So guys, what is the answer?
W.
PC. What is the answer for PC? ಎಲ್ಲೋ ಇದೆಯಾ ಆದಿತ್ಯ ನೀನು? ಕೋಳಿ ಕೂಗ್ತಾ ಇದೆ.
ಮನೇಲಿ ಸರ್.
What is the answer for PC? Hey, what is the answer for PC, man? How much time you need for this to calculate? It's already been 10 minutes.
Sir, I got 20.3 into 10 power 5.
20.3 into 10 power 5 is the exact value, man. Very good. So PC value is 20.3 into 10 to the power 5. What about the work done, Hazim?
2.5.
2 point?
22.5.
How much?
2.5.
2.5.
2.5 W.
2.5?
2.5.
2.5? What?
Yes, sir. 2 point.
ಏನು 2.2?
Sir, I got 22.5 kilojoules.
22.5 into 5, 10 per 5 joules, sir.
22.5 into 10 power 5. Okay.
Yeah.
So the right answer given in this is 2.25 megajoules. That means 2.25 into 10 to the power of 6 joules. Okay, that is the answer. Hope everyone got the problems and hope you have enjoyed the class solving these 4 problems. Okay, any doubts in these 4 problems?
No, sir.
Okay,
No, sir.
good. We shall solve some more problems in the next class. In the next class. Okay, till then, have a great time. Enjoy yourself. Take care.
Sir, that is present, sir.
Yes, sir.
Bharat, okay. Mark ಮಾಡಿದ್ದೇನೆ.
Okay, sir. Okay.
Sir, Srijan present.
Srijan, ಎಲ್ಲೋ ಇದ್ದೆ ನೀನು? Srijan?
You didn't call my name, sir.
Is it? Okay, fine. I
Yes,
have
sir.
marked you. I have marked you.
Thank you, sir.
Okay, fine.